Hi, I'm Dane. This is my Earth, Sun, Moon project. I wanted to make my model to scale, so I used Play-Doh. My moon is 1 1/3 inches. My Earth is 5 inches. And if I were to make my sun, which I didn't, because it's so big, it would have been 45 feet in diameter, which I would have needed to use 360,000 gallons of Play-Doh. As we're exploring the lunar cycles, I put the Earth and Moon a little closer together, but to scale, it would have been 12.5 feet apart from each other. And the Earth would have been 1,614 yards, or almost a mile, from the Sun. To understand the lunar cycle, we have to have a sense of how the mechanics work in our solar system and an idea of perspective. If you were on the perspective of the Sun, which you might have some problems with, you would see that there are no lunar cycles or Earth cycles. Everything would be lit up since you were the source of light. If you were standing on the moon, you would see the exact opposite of what we would see on the Earth. It would be fascinating to be on the moon when that happens because the moon is tidally locked. So the Earth would always be in the same position. Understanding the lunar cycles from the Earth's perspective is quite complicated because there are so many things in motion. The Earth orbiting around the Sun, the Moon orbiting around the Earth, and on top of that, the Earth is spinning on its own. To understand the lunar cycles, let's start with the new moon. The new moon is when the moon is closest to the Sun in its orbit. This means we see the dark side of the moon because the side that isn't facing us is lit up by the Sun. The moon orbits counterclockwise. The next part of the lunar cycle is first quarter. This is when the moon is right up next to the Earth and they're the exact distance from the Sun. Next, we have full moon, which is where the moon is farthest from the Sun in its orbit. This means the dark side of the moon is facing away from the Earth. The final moon phase is called third quarter. This is the second time when the moon is perfectly lined up with the Earth and they're the exact distance from the Sun. Since there are 28 days in the lunar cycle, there are little slivers in between the 4 quarters. These slivers are called either gibbuses or crescents. The crescent and gibbous can either be waning, which means it's getting smaller, or waxing, which means it's getting larger. In the image, you see that the moon is a waxing gibbous, which means it is becoming closer to the full moon. This is another picture of a waxing gibbous, but unlike the other image, it is much closer to the full moon. This next image is a waning gibbous, which means it is getting smaller and closer to the new moon. This image is even smaller and it is a waning crescent, which means it is getting much, much closer to being a new moon. This is the same position, but from a different angle. So you can see that where the moon is in its orbit. There are two different kinds of eclipses. This is the more dramatic kind that doesn't happen quite as often. It is called the solar eclipse, which means the moon is completely lined up with the sun and the earth. It is blocking the sun from part of the earth. The next eclipse is called the lunar eclipse, where it's the exact opposite and the earth is in the way of the sun. The earth has seasons because its axis is tilted about 23 degrees. This axis always faces the same direction, which means parts of the year it's facing toward the sun and parts of the year it's facing away from the sun. When the northern hemisphere is facing the sun, we get summer, and the exact opposite thing happens in the southern hemisphere. Like the moon, the earth orbits counterclockwise. This orbit takes about 365 days. This is what we call a year. When the axis is pointed away from the sun, it creates winter. In this image, it would be winter in the northern hemisphere. The southern hemisphere is experiencing summer.